a video that guides you through the entire process of the universe's birth. Approximately 13.8 billion years ago, the universe began to expand and cool from an extremely hot and dense state. Then, the Big Bang occurred, which is also known as the origin of the universe as we know it today. The explosion released the primordial energy of the universe. The clouds of gas, primarily composed of hydrogen and helium, were the most primitive material in the universe. Under the influence of gravity, these gas clouds gradually gathered, forming areas of higher density, and the first stars began to form. As countless stars congregated together, galaxies also formed. The interactions and mergers between galaxies can change their shapes and sizes. The formation and demise of stars also affect the distribution of matter within galaxies. After a long time, the distribution of matter within galaxies gradually stabilized, creating the types of galaxies we see today, including spiral and elliptical galaxies. The galaxies in the universe continue to evolve to the present. If wandering galaxies accidentally collide with each other, they will merge, forming larger galaxies. This process repeats itself, and eventually, galaxies can form galaxy clusters or larger superclusters. Throughout the evolution of the universe, many strange phenomena appeared, each with its unique beginning and end, creating miraculous wonders. We are also a part of the vast evolutionary process of the universe, although many people are not aware of this. Our Milky Way was also formed during this process, containing approximately over 200 billion stars. Gravity is both the creator of worlds and the ender of wonders. It resembles an immortal and strict program. A star with a mass 20 times greater than that of the Sun exhausts its nuclear fuel in its core, causing the core to collapse rapidly under the influence of gravity and explode violently. This process is known as a supernova explosion. The light from this explosion can be millions of times brighter than the Sun. The remnants of the exploded star will be scattered into space, and this material will gather again to create new stars. This process resembles a cycle of life and death. It is within this cycle that our Sun was born, about 5 billion years ago. Before exploring the solar system, let's see what happened to the giant star that exploded. After the supernova exploded, the material in the core was compressed strongly by gravity, causing the density to increase rapidly. The compression continues until the material is squeezed into an incredibly small point, which has extreme density and gravitational field, known as a singularity. The region surrounding this point is called the event horizon. Once matter or radiation falls into this region, it cannot escape from the strong gravity, and thus, a black hole is formed. We have heard the term black hole, but so far only understand its surface. The gravity of a black hole can easily tear apart a star, as if an invisible hand is pulling material from the surface of the star into its orbit. Black holes do not have a fixed shape that we can observe. Only hot material spins around them at high speeds. Black holes not only pull everything in, but can also eject material from their centers. We can observe this ejection, but we cannot see the black hole itself because even light cannot escape from it. Therefore, there are many speculations about black holes. Now, let's return to the Sun. After its birth, the Sun became the center of attention in this area. Many planets emerged around the Sun, including our Earth. Initially, Earth was just an unattractive planet. But after a collision with a large celestial body in the solar system, Earth received much new material, including elements like carbon, the main element that makes up all living things on Earth today. After the collision, the debris from the celestial body formed the Moon. When Earth was newly formed, it resembled a hellscape filled with volcanoes and harsh environments, showing no signs of life. But it was precisely in these harsh conditions that miraculous transformations occurred in the deep seas, where materials spewed from underwater volcanoes chemically reacted and created life. This process was not simple and required essential random conditions. Over 3 billion years, simple microorganisms evolved into the highest forms of life on Earth. As microorganisms thrived and dominated the oceans, they produced oxygen through photosynthesis, helping Earth escape from a thick layer of methane gas and become rich in oxygen. This laid the groundwork for the robust development of living organisms. Subsequently, Earth entered its most severe ice age in geological history. Yet the emergence of multicellular organisms marked the explosion of complex life. Many may be skeptical about predicting what happened billions of years ago when weather forecasts are only accurate for a few days. But thanks to pioneering explorers, humanity has reached heights that other animal species could not achieve in billions of years. To honor life, we must understand the great miracles of existence. It is the courage to explore and respect these wonders that has propelled humanity forward without ceasing.